Okay, a plane flies 1.5 hours at 110 miles per hour with a bearing of 50 degrees. It then turns and continues another 1.2 hours at the same speed, but with a bearing of 140 degrees. At the end of this time, how far is the plane from its starting point? What is its bearing from that starting point? So which figure most accurately represents this situation? Bearings are always starting from due north, and go clockwise. So started at due north and it was traveling 50 degrees. So this is its first flight. And then it again draw a due north whenever you make a direction change, and it changed 140 degrees. So this is its figure. What is the measure of angle ACE? As shown in the following diagram, if you draw the opposite ray for CD and label the point on the ray as point F, this can help you find the measure of angle ACE. So it wants to know this angle from A to C to E. The way this helps right here is it continues a line. This is 140 degrees out of 180 because it's a straight line. So I would have to travel another 40 degrees here to be able to continue this line. So I know that angle ACE is at least 40 degrees. I would also know that this intersects at 90-degree angle. Oh, we would also know that this line and this line are parallel. This is crossing two parallel lines, so this angle and this angle are alternate interior angles, so this is 50 degrees. So we have 50 degrees plus 40 degrees, so that is 90 degrees. Because you were given the speed and time, you can find the distance that the plane flew to arrive at point C and the distance it flew to arrive at point E. The original problem that stated that a plane flies 1.5 hours at 110 miles per hour with a bearing of 50 degrees. It then turns and continues another 1.2 hours at the same speed but with a bearing of 140 degrees. What are the measure of segments AC and segments CE? So segments AC, it was traveling 110 miles per hour. Actually, it was traveling 110 miles per hour for 1.5 hours. So what we can do is it's traveling 110 miles for every 1 hour. So I'm going to multiply that by the total time it was flying, which is 1.5. So 110 times 1.5 is 165. So it traveled a total of 165 miles. So AC is 165 miles, and I'm going to look for that. And since this is the only option that has 165 miles per hour, I'm going to verify that CE is 132. So we would do the same thing. It was traveling at 110 miles per hour for 1.2 hours. So we would have 110 times 1.2, and that's going to give us 132 miles, which is correct. And then it wants us to find what is the measure of side length AE. Round your answer to the nearest mile. So right here is side length AE. We know 50 plus 40 is actually a 90-degree angle. We have this side length, which is 165. We have this side length, which is 132. And we have this unknown side length. So since we have two side lengths, I can use, in a right triangle, I can use Pythagorean theorem. So we have that, we have a squared plus b squared is going to equal to c squared. Now c squared is always c is always the hypotenuse, and so hypotenuse is always across from the 90. So AE is actually the hypotenuse, and then I'm just going to label this as A and label this as B. So when we take this, that's our Pythagorean theorem. When we use this, we're going to use substitution. A is 165, so I'm going to type in 165. B is 132. And C is what we are trying to find. So I look, is C left to itself? So is it just 1C? No, it is C squared. So then I'm going to use square root to because it is the inverse operation to a squared. So since C is being squared, I'm going to square root both sides. And so we would actually have the square root of 165 squared, and this is being square rooted. When you square root something being squared, it undoes it. So it makes it just C, and then we would type this into our calculator. So we would type into our calculator the square root of 165 squared plus 132 squared. Close parentheses. And it's 211.303. So when we come back, it says round your answer to the nearest mile. Since this is less than 5, this is 211 miles. Now, what is the bearing of the plane from the starting point? Round your calculations to the nearest degree. So from the starting point, so they are wanting to know what the bearing is from our starting point. So since our starting point was here, we are now over here. If we were to draw a line from due north to this, that is the angle that they want us to find. So we know this is 90. We have this as 211. So the only part of this that we could still use to find is this portion of that angle. Then we're going to add 50 degrees to it. Now, why do they say hint use inverse trigonometric ratios? It's because inverse trig functions are used to find angles, like inverse sine, inverse cosine, inverse tangent. They're used to find angles. Regular trig functions, like sine, cosine, and tangent, are used to find side lengths. So inverse trig functions are the ones that look like they have a negative 1 as an exponent. So sine inverse, cosine inverse, and tangent inverse. Whoa, that wasn't supposed to be a double. So that's why they are saying hint use trig inverse ones. So now if we look at this question, we're trying to find this angle and we have all of the side lengths. So we could use any one of these inverse trig functions because we have all of the side lengths. I personally would use the 165 and the 132 miles because those were the two information that is given first. So based on this angle, this would be the hypotenuse because it's opposite 90-degree angle. This angle's our perspective. So this would be our opposite side length, and this would be the adjacent side length. So we would have tangent inverse. So the angle, I'm going to call it angle A, is equal to tangent inverse of the tangent ratio is the opposite side length divided by the adjacent side length. So I'd have 132 divided by 165. And then I'm going to jump over to our calculator and make sure I'm in degrees. Hit the inverse button, tangent of 132 divided by 165, hit equals, and that's going to equal 38.65 degrees. So that is what this inside angle right here is equal to. Now remember the bearing is from due north straight down to this line. So I'm going to take 38.65 and add 50 to it to find that total angle. So 38.65 plus 50 degrees is going to equal 88.65 degrees. Now it says round your answers to the nearest degree, so rounded, that would be 89 degrees. And I hope that helps.